Hello, welcome to part 3 of chapter 4 in our summary statistics. In part 3 we're going to be going over 4.7, which is the spread and standard deviation. It's the most common descriptive measure of spread. It's based on deviations around the mean, right? Standard deviation, it's a deviation around the mean. The figure demonstrates the deviation of two of its values. So here we're going to have an example of deviations of two observations from site 2 of the air samples. So in this data set we have our x bar, or mean, equaling 36, right? So here it is represented 36. Now if we were to take the data point of 32 and the data point of 40, the deviation between that data point and the mean is what we're calculating. So deviation would be the data point of 32 minus the mean, which is going to give us a value of -4. The data point of 40 to the x bar, or mean, is going to give you a value of 4. So we would say the deviations from these data points are either -4 or 4, as shown with this example here. So when we talk about the deviation is the distance between that data point and the mean. When we talk about standard deviation, it's the deviation around the majority of data points around the mean, right? It's based on the deviations around the mean. Variance and standard deviation. So here are our formulas for figuring out our variance and standard deviation. First thing, as we went over, is the deviation itself, which is notated by x subscript I minus our x bar. So the value that we are looking at, x subscript I, minus our mean, or x bar. So exactly what we just did right here. This would be your x subscript I minus your x bar, which we actually have values for. So we have x, so this might be x subscript 1, which is a value of 32, minus our x bar, a value of 36, equals our deviation of -4. Next up, we have our sum of squares deviation, notated by SS equaling capital sigma times the quantity of x subscript I minus x bar, which this should look familiar. This part is just a deviation. So it's the deviation squared all added together, our sum, right? Our sigma. So when you take the deviation, you square it, add them all together, you get the sum of squares deviations. Next is our sample variance, which is notated by S squared. This is our SS, which is the sum of squared deviations, divided by our n minus 1. N, as we know, is the number in the data set, so -1. So you take your deviations that are squared, add them all together, and then you divide by n minus 1, and that will give you your sample variance. If you have your sample variance, you can figure out your standard deviation, which is notated by S equaling the square root of S squared. This S squared is your sample variance. So you take the square root of your sample variance and it gives you your standard deviation. Give you a second to just look this over, let that settle for a second. We're going to be doing multiple examples of this, and I'll show you one coming up. When you look at the standard deviation formula, S, standard deviation, is equal to the square root of 1 over n minus 1 times the sum of x subscript I minus our x bar squared, right? And if you look at that, it's all of these steps just combined together. When we look at it, this is our deviation. When we square it and add it all together, that's our sum of squares deviation, divided by n minus 1, which gives you to your variance, and then you take the square root of it, and that's going to give you your standard deviation. A sample standard deviation, S, is the estimator of population standard deviation, lowercase sigma. You can see more about standard deviation on page 93 of our book. Once again, I just did that. So here's where all the work starts to really play out. So our illustrated example. So right now I just want you to all look at the observation. This is our data set that we have. Okay. When we have our data set, first thing you have to do is we have to find our average, which we already have done, but just to illustrate it, you would add all of the values up here, divide by the total number, and you get your average, which is going to be 36. X bar equals 36. Next step in our standard deviation process is once you figure out your average, you are then going to do the deviations. So you take your 36 minus 36, and you get your deviations, which is notated here. 38 minus 36, which gives you your notation here. And you keep going all the way down till you finish. These are the values of your deviations. To get your squared deviations, you take the value that you got from your deviations and you square it. 0 squared, 0. 2 squared, 4. 3 squared, 9. You do that all the way down, going over, and you'll have these values, and then you add them all up, right? Remember, this is where we have the sigma where we add them all up, and we get a value of 58 for our squared deviations. Since we have our value of 58 for our squared deviations, we can plug that into our formula, which was for our sample variance, s squared equals ss over n minus 1, which we have 58, minus our n minus 1, n is 8, 8 minus 1 is 7. When you take 58 divided by 7, it's going to equal 8.286. Next part of our formula to figure out standard deviation. First formula for standard deviation at this point will be s is equal to the square root of s squared. We already figured out s squared. Don't let this confuse you. S squared equals 8.286. When you take the square root of this, which is exactly what we're doing right here, you're going to get a value of 2.88. That is our standard deviation. So on in test or example, when we have a data set maybe shown here and I say calculate the standard deviation, these are the steps that you take to calculate the standard deviation and then report it as such. Once again, review this, go over it. We will be practicing this. This is key. So the interpretation of standard deviation. It's the measure spread. An example, if a group of S1 equals 15 and group 2, S2, or standard deviation, is 10, then group 1 has more spread. Reason why we start talking about standard deviation and the spread is because we can start using this information to run our statistical methods that are going to be coming up. But we need our standard deviation to find our average around the mean. The next two things we're going to talk about are the 68, 95, 99.7 rule and the Chebyshev's rule. The 68, 95, 99.7 rule is only for normal distributions. Anything that is not a normal distribution, the rule does not apply to. When we say it's a normal distribution, what we say is the distribution is normal. There is a bell-shaped curve to it. If there's not a bell-shaped curve to it, we cannot use the 68, 95, 99.7 rule. What this rule states, and this is the rule that we will use, we won't be using Chebyshev's rule, I'll go over that in the next slide, but we won't be using that rule, I'll explain it. But the 68, 95, 99.7 rule is the one we use. And with that, we can tell a lot about data. What the 68, 95, 97 point rule is that we say 68% of the data is in the range of our mu, or we can say x bar, depending on if we're looking at sample or population averages, plus or minus our standard deviation. So if you had a standard deviation and you know the x bar or mu value, when you add those together, we can say that 68% of the data is incorporated in that range. When you go out two standard deviations from the mean, add it from the mean, you incorporate 95% of the data. And when you go out 3 standard deviations from the mean, you incorporate 99.7% of the data. So example shows the variable has a normal distribution of 30 and a standard deviation of 10. Then you would say, with our standard deviation of 10 and our mean of 30 plus or minus 10, we would say that of this spread, 68% of the values will fall between 20 and 40. 95% of the values, when we go 2 standard deviations out from the mean, will fall between 10 and 50. When we go 3 standard deviations out, we're encompassing 99.7% of the data, and then we would say the values are going to be between 0 and 60. If this slide is not making a whole lot of sense right now, don't be too scared with it. This will be carried out and go into crazy more detail. For now, understand that when we use the 68, 95, and 99.7 rule, this is what we're referring to. Excuse me, sorry about that. Had something really caught in my throat. Like I said, if it doesn't make a whole lot of sense right now, don't be too frustrated. We will get into this more. Just know that it's only for normal distributions. Know that it's related to percents of the data in that range. Chebyshev's rule is similar, but at least a little different. Chebyshev's rule says that at least 75% of the values will fall in the range of your mu plus or minus 2 standard deviations for any shape distribution. So a distribution with a mean of 30 and a standard deviation 10 has at least 75% of the values in the range of 30 plus or minus 2 standard deviations, which is from 10 to 50. We don't go into Chebyshev's rule too often. In this class, we're not going to go into it at all. We're really only going to be focusing on the 68, 95, 99.7 rule when it comes to standard deviations with normal distributions. So here we have birth weights as an example. So here's our data set. We want to find the mean, median, standard deviations. For it, this is the standard deviation set we'll be practicing in class coming up. So if you would like to take a stab at it, have this ready for when we go into class. This will be a great example of practicing it, and then we can go over it as one of the first things we do to really practice and hone our skills on finding the standard deviation. Rules for rounding. I may have talked about this briefly in the before, but just to really hammer it home, we're going to carry at least 4 significant digits during calculations. So you want to go at least 4 decimal spots deep. You want to round as the last step of the operation. You don't want to always round while you're doing it, because then the end value is not going to be as accurate because you're always rounding. You're not going to be crazy off if you do it, but you will be off if you don't do it. This is to avoid pseudo precision, right? False precision. When in doubt, use APA publication manual. Always report the units. Always use common sense and good judgment. So choosing summary statistics, always report a measure of central location, a measurement of spread, and the sample size. So a central location would be anything like our mean, median, mode, the measure of spread, range, or quartiles, and then the sample size. I'm going to try to finish up really quickly to finish this video with symmetrical round-shaped distributions report, the mean and standard deviation, odd-shaped distributions report, 5-point summary, IQR, and lastly, always use software and calculators to check your work. Once again, you can use calculators and software to do the work, but when it comes time to the test and you have to do it and you haven't practiced doing it longhand, it's not going to help you. So practice, use calculators as a guide to help you and other software. That's all I have for this video, and I will see you all later.